Welcome to the Module 7 Research Spotlight. Module 7 focuses on protein, one of the three macronutrients and the one athletes ask about most. You have read about protein structure, digestion, amino acids, and how to calculate protein needs for active individuals. This presentation connects that content to real published research and prepares you for the assignment that is due this week. Before we get into the study, let me quickly review what protein does and why it matters for athletes. Protein is essential for building and repairing muscle tissue, producing enzymes and hormones, supporting immune function, and maintaining fluid balance. For athletes, the recommendation is 1.6 to 2.2 grams per kilogram of body weight per day, significantly higher than the general population RDA of 0.8 grams. And as Chapter 7 emphasizes, it is not just total intake that matters. When and how protein is distributed across meals is equally important for maximizing muscle protein synthesis. That is exactly why this study examines. The article is titled Protein Intake in NCAA Division I Soccer Players by Kwan and colleagues, published in 2023 and actually conducted at my alma mater, Cal Poly San Luis Obispo. So now, before reading any research article, you need to confirm it is primary research for this assignment. Here is how. Look for four things. First, original data collected directly from participants, not summarized from other studies. Second, the article has introduction, methods, results, and discussion sections. That four-part structure is the hallmark of primary research. If there is no method section, it is likely a review article. Third, it is peer-reviewed and published in an indexed journal. And fourth, it received IRB approval, meaning the study was reviewed and approved for human subjects research before data collection began. This study meets all four criteria as it is listed here. And when you search PubMed for your own article, use these same four markers to confirm that you found primary research as well. So when we look closer at this study, the purpose of this study was to examine how much protein NCAA D1 soccer players consume daily, how that protein is distributed across meals, and whether the quality of that protein, measured by the leucine content, is adequate. Participants were 36 soccer players, 13 men and 23 women from Cal Poly San Luis Obispo, data collected at the start of the competitive season. The method was that athletes completed 3-day food diaries. Results were compared against UEFA expert group guidelines, 1.6 to 2.2 grams of protein per kilogram per day, at least 0.4 grams per kilogram per meal, and at least 2.5 grams of leucine per meal. When you summarize your own article for the assignment, this is the structure to follow. State the purpose, describe who was studied, explain what was done, and identify the standard or comparison used. 4 findings from the data, the key findings from this study. 1, daily protein. Men averaged 2.08 grams per kilogram per day. Women averaged 1.38 grams per kilogram per day, which would be below the minimum. 77% of men met guidelines versus only 35% of women. Second, the distribution. Only 11.1% of athletes met the protein threshold at breakfast, 47.2% at lunch, and 77.8% at dinner. So most protein was consumed in the evening, which is not the most effective pattern for maximizing muscle protein synthesis throughout the day. Number 3, leucine quality, the amino acid. Men had an actual to ideal leucine ratio of 82.8% versus 52.2% for women, a statistically significant difference. Female athletes were less likely to consume enough leucine per meal to fully trigger muscle protein synthesis. Then number 4 here is energy intake. Both groups were consuming below the estimated daily energy expenditure. When athletes are in an energy deficit, protein gets used for energy rather than muscle repair, which can be a compounding problem. Athletes need a lot of calories, and sometimes it's not easy to consume enough to get all the nutrients that you need. So when we apply this and evaluate it, your assignment asks 2 questions. Can these findings be applied to athletes, and what are the limitations? On applicability, yes, these are well-trained collegiate athletes studied during the actual competitive season in real-world conditions. The findings are directly relevant to sports nutrition practice. The intervention point is also immediately actionable. If only 11% of athletes are meeting protein goals at breakfast, the recommendation is simple. Maybe add eggs, Greek yogurt, cottage cheese, or a protein shake to the morning meal. On limitations, the sample is small. It's only 36 athletes from one institution, which limits generalizability to other sports or other athletes. The data are self-reported, which means intake may be somewhat underestimated, and the study did not assess protein timing relative to training sessions, a gap the authors acknowledge in their publication. So overall, the conclusions are well supported by the data and consistent with what we've learned and covered in Module 7. So 4 takeaways here is that total protein intake is necessary but not sufficient. Distribution and leucine quality matter equally. Breakfast is the most consistently underfueled meal. Female athletes consume significantly less protein and leucine than male athletes. And even well-trained athletes frequently fall short of evidence-based guidelines. And then for your assignment, you go to PubMed, find a primary research article on a sports nutrition topic of your choice. Maybe you want to look up leucine now. And then confirm it meets the 4 primary research markers from slide 1. Read the full text and write your evaluation covering purpose, participants, methods, key findings, applicability, and limitations. Okay, this is an important assignment, and you may use this presentation as your model, and of course, ask your instructor if you have any questions. Best of luck.